Okay, we're going to be covering articulations. There we go. Okay, so articulations in joints, otherwise known as joints, can be classified two different ways, or we generally classify them two different ways. We either can classify all the ones we're going to be looking at structurally or functionally. All right, structurally means we're going to look and identify the material or the type of tissue that's holding bones together. It's either going to be fibrous tissue, like dense, regular connective tissue, a cartilage, one of the hyaline, elastic, or fibrocartilages. I'll tell you it's really just going to be hyaline or fibro. And synovial, which means that you have, synovial joints are highly movable. You have synovial membranes with fluid in between the two ends of the bone, and we have hyaline cartilage at the ends of the bone. And I will tell you that those are very abundant in the body because most of our joints have to be quite movable. So when we structurally classify, we're going to say either your possible answers are fibrous, cartilage, or cartilaginous, or synovial. Or we could take those same joints we're going to look at and classify them functionally. How much movement will be occurring here? And this will, after a while, be kind of make some sense to you. And your possible answers are synarthrotic, amphiarthrotic, or diarthrotic. Right? From the least amount of movement, virtually like no movement, to the most amount of movement, synarthrotic, amphiarthrotic, diarthrotic. Okay, so let's look at the fibrous joints. Bones are joined by fibrous connective tissue. Example of these are the sutures we looked at. The coronal suture, the sagittal suture, squamous suture, lambdoidal suture. Gomphoses, which is really a new term, but they're your tooth sockets, essentially. We have ligaments that hold the teeth in your tooth sockets. A syndesmosis is a joint held together by a ligament. We have those, especially around the distal end of the fibula. That's a good spot. Right? But, crossing joints like the shoulder joint. And then we have interosseous membranes. And these are kind of sheaths of connective tissue that join the radius to the ulna in the forearm and the tibia and the fibula in the lower extremity. All right, so sutures, fibrous connective tissue here, holding those together. A syndesmosis, the distal end of the fibula, to the tibia. And even to the talus, there's multiple ligaments technically. Gomphoses, which are ligaments that hold the teeth in their tooth sockets. Cartilaginous joints are joined by cartilage. So it's going to be either one of these hyaline or fibrocartilage locations that we looked at, not only when we talked about, the cartilage. Well, most of those we looked at when we looked at the cartilage and hyaline cartilage locations, in the lecture material in the first chapter of skeletal tissue. So a synchondrosis is the connection is hyaline cartilage. And it's bone, hyaline cartilage, and more bone. So an epiphyseal plate, those open growth plates and long bones, right, that would be a synchondrosis. A symphysis, our two locations for you to know are going to be fibrocartilage locations, the pubic symphysis and the intervertebral discs. Pubic symphysis and intervertebral discs. Right. So here we have a synchondrosis. This is a great example, where we have the epiphyseal plate, proximal and distal on these long bones, and over here between the first rib and the sternum, that's another location. If you would like to know that, it's not one we generally identify in lab, but that is technically one as well. Then below that, we're looking at our symphysis types of joints. The pubic symphysis to the right, that you're familiar with, and the intervertebral discs between two vertebrae. All right, or we have synovial joints if we're going to structurally classify. And these are articulating bones separated by a membrane-bound, fluid-filled cavity. These are very abundant because when we have synovial joints, it's going to impart a lot of movement. So all these structurally classified synovial joints, when it comes to functionally classifying them, they're going to be diarthrotic, which means highly movable. Okay, so the Fibrous joints and the cartilaginous joints, those are the ones that may be classified as either synarthrotic or amphiarthrotic. But when all synovial joints are considered diarthrotic functionally and vice versa. Okay, so the bone, the epiphysis, the articular cartilage that covers the ends of the bones because it reduces friction and acts as a shock absorber. All right, so that's found in synovial joints. We have the synovial membranes that surround them and the fluid between them. All right, that also reduces friction by lubricating the joint and absorbs shock as well. All right, so here's an example between two phalanges, essentially, is that we have the blue, which is always your hyaline cartilage areas, the articular ends of the bone. Right. Then out to the sides, you can see these synovial membranes, and the light green is the fluid in between. Okay, if we want to functionally classify joints, your mnemonic is SAD. Synarthrotic, amphiarthrotic, diarthrotic. Synarthrotic are immovable joints. So of the ones we've just mentioned, and we look at a lot in lab, the sutures, the gomphoses, the tooth sockets, and the epiphyseal plates. Right, look, if someone pointed to a suture on a skull, how much movement would you expect to be between those bones? None, right? Between the tooth and the tooth socket, unless you have periodontal disease, there shouldn't be any movement of your teeth in your socket there. Those ligaments should be holding it in place. And then when we look at epiphyseal plate, the movement between an epiphysis and diaphysis of a long bone, there shouldn't be any movement there. So that should kind of make sense. If I pointed to a suture or gomphosis or epiphyseal plate, and said, what is the functional classification of this joint? You go, well, it has to be the S of SAD, and they all end in throtic, all right? So it would be synarthrotic because those are the least movable or immovable. Amphiarthrotic means slightly movable, right? So the disc between the vertebra, that has some movement. The pubic symphysis, thank goodness, that has some movement. And the interosseous membranes between the tibia and the fibula, and the radius and the ulna, right? That allows your forearm to twist and turn. It allows you to supinate and pronate, right? And then the diarthrotic joints are the freely movable joints. Those are all the joints that are going to be synovial joints. And essentially, out of really fairness, anything that isn't captured here as synarthrotic or amphiarthrotic, never point to a suture, a gomphosis, epiphyseal plate, intervertebral disc, pubic symphysis, or an interosseous membrane. If we point to, or someone points to those, then at least it's a 50-50. Synarthrotic, no movement, or some movement. Any other joint we point to is going to be a synovial joint, and therefore it's going to be a diarthrotic when we classify it functionally. Okay, so to go over some basic terms, origin is the attached or is the end of the is the bone that is going to be the immovable bone when the muscle contracts. So muscle is attached to two different bones. Okay, otherwise, if attached to the same bone and the muscle shortened, nothing would happen, right? So muscle is attached to two different bones. One is generally the immovable or less movable bone, right? And then the other is the more highly movable bone. Origin versus insertion. Movement occurs when insertion moves closer to the origin. Movement may be described in terms of axes, and range of motion varies. Okay, so types of angular, movements that are occurring at synovial joints are things like flexion, extension, and hyperextension. So I'm going to kind of define these, and we're going to look at some examples of these. Flexion decreases the angle, bringing bones closer together. And extension increases the angle. It's the reverse of flexion. All right, so let's say we were doing a biceps curl, and you have your arms extended. You're in anatomical position. I flex the elbow, my biceps brachii, and we flex the forearm. Your palms come close to your shoulders, right? That would be decreasing the angle, and that would be the biceps brachii muscle primarily working. To extend, means you're going to do the reverse reaction. You're going to return to anatomical position and straighten out the elbow. That would be the action of triceps brachii, right? All right, so flexion versus extension. The same in the leg. When we flex the knee, so to speak, we flex our hamstring muscles and your heel comes close to your butt, or we can extend the leg and straighten the leg, and that would be extension. Hyperextension is beyond the anatomical position. It doesn't mean that it's abnormal necessarily, because we have normal areas of hyperextension. For instance, in the neck, when you're in anatomical position, your cervical spine, you're looking forward, right? You can flex, bringing your chin toward your chest, and extend to come back to anatomical position, your head straight up, looking forward. But you can also let your cervical spine hyperextend and let the back of your head, your external occipital protuberance maybe, extend backward toward your spine, tilting your head back so you can look, straight up to the ceiling, or to the sky. And then back to a normal position, to anatomical position. That would be hyperextension. The same with your lumbar spine. When you bend forward to touch your toes, it would be flexion. Coming back to anatomical position would be extension. But if you kind of back bend back, which some of us can do more easily than others, that would be hyperextension. Okay, we have types of movements such as supination and pronation. As I was describing in the forearm, in anatomical position, right? You can your arms out to the side. I can turn my palms toward the back or toward the wall, and then that's called pronation. And supination is turning them back so palms forward. If you have your arms extended in front of you, like you're holding, a bowl of something, let's say, in front of you, or a plate of food, all right, where you have your elbows flexed, palms up is supination, palms down would be pronation. Okay, we have abduction and adduction, and then circumduction. So AB in Latin means away, so abduction, abduction is movement of the bone away from the midline, such as, as you're in anatomical position, right? Maybe raising your arms out to the side and eventually kind of right by your ears. That would be abduction. Adduction means returning them back down to your sides. Adduction means like adding two numbers together. So AB means away. In the legs, if you were leaning down on your back legs, or let's say you're standing in anatomical position, right? You lean over to the left side so you can bring your right leg out to the side. That would be abduction. And returning your leg to where you're standing upright and both feet on the ground would be adduction. Circumduction is circular movement of the bone. So that the kind of movement that occurs in your shoulder joint, if you swing your arm all the way around, full range of motion at the shoulder joint, or at your hip joint, your leg can make great big circles. And also the base of the thumb, you can make big circles. That's circumduction. Rotation, right? The bone revolves on an axis. So a really good location is atlas on axis, C1 on C2. Right? If you stand in an anatomical position, or you sit in anatomical position, so to speak, right? And you don't move your shoulders or your body, but you just look to your left shoulder and your right shoulder, left shoulder and right shoulder. Right? That turning your head back and forth like you're shaking your head no, right? Requires atlas, that ring bone, to pivot on the dens or the adenoid process of C2, and that would be a great example of rotation. Okay, so there's some other movements such as dorsiflexion and plantar flexion. And good example of that is the foot. So and you consider anatomical position. So you have your foot not totally flexed, but on the ground, right? From there, you can plantar flex. You can kind of go up on your toes like a ballerina. That would be plantar flexion. And then you could also go back to a neutral position, standing upright, and bring your toes as close as you can toward your nose or toward your shin. Right? Now that you understand that direction, you can do that sitting, right? You can point your toes in plantar flexion, come back to neutral, and then bring your toes as far as you can toward your nose or toward your shin. That would be dorsiflexion. Elevation and depression. Well, the mandible is a good location. Remember, the mandible pivots in that mandibular condyle, all right? So dropping or lowering the mandible is mandibular depression, and bringing it back, closing your mouth, would be elevation. We elevate and depress the scapula too, as it slides kind of along the ribs. When you shrug your shoulders, whoops, let me just turn this off. Whoops, my phone is ringing, so sorry. There we go, and I can't get it to turn off. There we go. Okay. Sorry about that. I put it on mute, and it only mutes the text and nothing else. So the scapula, as you shrug your shoulders upward, the scapula elevates and slides on the ribs. And then when you let your shoulders drop down, you depress the scapula. Okay, other types of movements in the synovial joints, because we can describe the types of movements in synovial joints rather specifically. They are generally plane, hinge, pivot, condylar, saddle, and ball and socket. And so I'll explain how these work. Plane joints are the types of movement between your carpal bones and your tarsal bones. So the bones, those 2 rows of 4 bones that form the wrist, and the bones that form the ankles. All right. They're rather squarish and usually shaped, and so they really just move in a singular plane of movement. They're not pivoting and spinning at all. They're just kind of going kind of up and down against 2 flattened surface virtually. Hinge joints, your elbows and your knees are great hinge joints. So is your ankle. But your elbows, flexing your elbow and extending, and flexing your knee and extending, those are good examples. That's why I put them in red. Pivot joints, like the atlas and axis we described before, and also how the radius moves on the ulna when you pronate and supinate and you don't move your shoulder joint at all. Just palms down, palms up, palms down, palms up. Those are, pivot joints. The condylar joint, example of that, are your metacarpophalangeal joints. So between the metacarpals in your fingers, at your big knuckle ridge, and in your feet. Hold on, this is happening. Let me just put this on. Hold on just a moment. I'm going to stop this share just for a moment so I can, I'm not sure if the kids are calling. So, okay, sorry, you guys. I tried to reblock my phone. I don't know if it's going to work. All right, let me reshare again. Hey. Okay, so we are moving up. We were talking about condylar joints. So yes, between the distal metacarpals and your finger, the phalanges, right? At the big knuckle ridge, that's what we're talking about, flexing at that point and extending. Then we have saddle joints at the base of the thumb, all right, the metacarpal bone to those carpal bones, which allows your thumb to kind of circumduct like that. That's a saddle joint. That's a really good example. And then ball and socket joints are the circumduction joints we just talked about, shoulder and hip. Saddle joint has a certain amount of circumduction as well, because it's considered circumduction, but the surface is more like a horse's saddle. That's why they call it a saddle joint. So the saddle joints and the ball and sockets, they have a good amount of movement there. Okay, homeostatic imbalances of joints. Well, we have osteoarthritis, which is a degenerative joint disease that occurs with aging, obesity, and wear and tear. Virtually as long as you live a long life, we're all going to end up with osteoarthritis. Does that mean it's not uncomfortable and really, really painful? No. It just means that these synovial joints especially start to wear down because you use them a lot. They're often the weight-bearing joints like your knees and your feet, and in your spine, as well as your hips, anything that's weight-bearing, but also fingers because you use them so repetitively. All right, so that's not uncommon. It's often a wear and tear type of an issue as we get older. Rheumatoid arthritis is an autoimmune disease. Now, that's something else where you start to make antibodies to some of the cells that form cartilage and the synovial fluids in the membrane. Areas that are most affected are your fingers, wrists, ankles, and feet. And then gout is actually rather common as well. Right? This is when uric acid builds up in blood and crystallizes into joints, the kidneys, and the outer ear. Inflammation of the big toe, it gets very swollen and red is usually your first sign, and that's called podagra. Tophi are these nodular crystallizations on the pinna or the auricle of your ear. You may see those in individuals. So it's when uric acid builds up in the blood and crystallizes in joints in the kidneys and the outer ear. Those are the big areas. And one of the first signs is swelling and redness of the big toe without the other digits being involved, believe it or not. Something that's good, was always recommended, is cherry juice when you have gout. Okay, these are, if you put this in slideshow mode, if you download these PowerPoints and you put them in or presentation mode, which I'm doing now, when you click on these should take you to some games that you can play, that are timed, but you just drag and click. So those are rather helpful to, it's something to practice and learn how these joints work. And then let me go back to, I think it just broke the share. Hold on. Let me stop it and go back. I forget this sometimes when it takes you to a web page, it might not share it, but I don't know if you saw it or not. But when you click on this, it'll take you to like an interactive game. And then there was another one, I think. No, that's not that one, just that one. Let me do it again and see if I can change my share. There we go. Hopefully this is captured. Okay, so this is where it says classification of joints. You can start this here. You're going to drag and click. It's going to bring up different types. And it tells you how to play down the bottom. Start now. So you can, I think that's kind of fun. Okay, well, that is the end of the presentation.